Hello dear students, so welcome back again to the lecture number 33 and we are at the end of the exercise number 8.2 and after this lecture we are starting or we are going to start exercise number 8.2 and this is the last video that I am going to upload in YouTube and after this lecture I think I will share you some YouTube videos from some confined channels, right? And I will not upload any video anymore. So this is the last video in YouTube that I am going to upload today. So in this lecture we are going to start another example from an NCERT book, that is example number 8, right? So let us understand the statement. So the question is L, M and N are three parallel lines. Okay, so let us first draw three parallel lines. Line L, line M and line N. Okay. So L, M and N are three parallel lines and they are intersected by, okay, they are intersected by two transversal lines P and Q. Let's say these three parallel lines are intersected by a transversal line. Let's say the name of the line is P. Okay, so this line intersects all these three parallel lines at three distinct points. Suppose the name of the point is A, B, C, right? A, B and C. And there is another transversal line whose name is Q, which also intersect all the three parallel lines. Let's say this is the another transversal line Q. And this line also intersect the parallel lines at three distinct points, right? So the name of the point are D, E and F. Oh, okay, so this is the diagram. Now, such that L, M and N cut off equal intercepts A, B and B, C. What is the meaning of equal intercepts? Let us understand it. So it is given P is the transversal line. Okay, we are considering only for this transversal line P, which is transversal to these three parallel lines. Now whenever this transversal line intersects these three parallel lines, it meet at A point, at B point and at C point. Okay, so it cut this line at A, cut it at B, cut it at C. Okay, so that you can see the distance between these 2 points, the distance between these 2 points where the transversal line pass is called an intercept. What is it? It is called intercept. Similarly, the distance between these 2 points where the line pass or where the line cut these two parallel lines is also called an intercept. So here we get two intercept. This is an intercept, the distance from A to B, and this is also an intercept, the distance from B to C. Is it clear? Now it is given that LMN, the transversal line P intersect LMN and cut off equal intersect AB and BC. So it is given that this intercept and this intercept, AB intercept and BC intercept are equal. Ultimately, you have to understand that the distance from this is equal to the distance from this. Okay, is it clear? So this is known as intercept. Intercept is the distance between 2 points where the transversal line cut the parallel or any other lines. Clear? So it is given that this AB intercept is equal to BC intercept. Now, if it happens that you have to prove so that L, M and N cut off equal intercept D and EF on Q, it means like in the P transversal line, the Q transversal line also intersect L, M and N at three distinct points D, E, F. Then how many intercept formed here? Here also two intercept forms. D, the distance between D and E is an intercept. The distance from E and F is also an intercept. So here also two intercepts form. DE, here DE and EF. And we have to prove that these two intercepts are equal. What are they? They are equal. Okay, now it is clear. So initially it is given that whenever the P transversal line intersect these three parallel lines, it forms two intercepts AB and BC. And AB and BC are equal. And you have to prove that whenever this transversal intersect this three parallel line, it also found to intersect DE and EF. And we have to prove that these two intercepts are equal. Understood? So let us first write what is given in this question. So it is given what? That L line is parallel to M line is parallel to N line. L parallel to M parallel to N. Clear? P and Q are transversal. Q are transversal. Then the intercept AB, the intercept AB is equal to BC. This is given. Okay. We have to prove that the intercept DE is equal to intercept EF. DE is equal to EF. We have to prove this. Clear? So let us prove it. In order to prove it, we have to construct something. What we will construct? We have to join the point A and F. We have to join the point A and F. Simply. Okay. So construction. Join A and F. Why I have joined A and F? Because if I join A and F, then I can get a triangle. Okay. See, if I join A and F, here I get a triangle. Here also I get a triangle. So I can get a triangle. That is the reason why I have joined A and F. Understood? So now let us prove. Okay. So let's say this point is G. Okay. So now we will consider the triangle AC and F. This triangle AC and F. So in this triangle it has three sides. Side AC, side AF and base CF. Right. So in this triangle, as you can see, for the side AC, B is its midpoint. Why? Because already it is given that this intercept is equal to this intercept. It means the distance AB is equal to the distance BC. So ultimately we can say that B is the midpoint of this side AC. Clear? So for triangle ACF, B is the midpoint of AC. Okay, B is midpoint of AC. Is it clear? Now, already it is given that M line is parallel to N line, isn't it? Yes, because L and M are three parallel lines. So this line M is parallel to this line N. Okay, it means BF is parallel to BE, this is E. So BE is parallel to CF. Okay, and BE is parallel to CF. Clear? If BE is parallel to CF, then we can write that BG, which is a part of BE, is also parallel to CF because BG is a part of BE. So you can write implies BG is a part of what? B, so it is parallel to CF. Are you clear? So in the triangle ACF, what we have got? We have got B is the midpoint of AC and BG, this BG is parallel to the third side CF. And this is a line segment. This line segment passes through the midpoint of one side of a triangle. And according to the theorem 8.10, we know, we have studied, if a line segment passes through the midpoint of one side of a triangle and parallel to the another side, right, like this, just see this. If this is a line segment, okay, and it passes through the midpoint B, and this line segment is parallel to the third side, sorry, parallel to the another side, then according to the theorem 8.10, we know that this line segment passes through the midpoint of the third side of that triangle. This is theorem 8.10 states. Okay, so here also BG is a line segment which passes through the midpoint of AC as well as it is parallel to CF. So ultimately we can say that this line segment BG passes through the midpoint of this side, third side AF. Okay. Hence, what we can write? BG passes through the midpoint of SC. It is due to theorem 8.1. It means what? It passes through the midpoint of F. It means what? It means G is the midpoint of F. Okay, so it means G is the midpoint of F. G is the midpoint of AF. It means what? It means the distance AG is equal to the distance GF. Is it clear? So implies AG is equal to GF. Okay, so here BG is the line segment passes through the midpoint of one side of this triangle and parallel to the another side. That means this line segment must passes to the midpoint of another side F. So G is the midpoint, so AG is equal to GF. This is clear. Okay, so this is the conclusion that we have got. Okay, so next we will consider another triangle, the triangle ADF. Okay, so again for triangle ADF. Okay, this triangle ADF. Okay, so in this triangle, this is the vertex. Okay, this is one side, this is another side, this is the base. Okay, like this, like this, like this, like this. Okay, base. These are the three vertex and three sides. Here. Now, in this triangle, as you can see, AF is a side. F, this is F, A, F. Okay, this is D. So AF is a side, and G is the midpoint of AF. G is the midpoint of AF, isn't it? Yes, because recently we have proved G is the midpoint of AF. G is the midpoint of AF. So we can write G is the midpoint of AF. Is it clear? Okay, then already we know the line M is parallel to L. It is given M and L are parallel lines. If M is parallel to L, it means BE is parallel to AD. Okay, BE is parallel to AD. So, and BE is parallel to AD. Okay, if B is parallel to AD, then we can write that G is the part of BE. So, G must be parallel to AD because G is the part of BE. So, implies GE is parallel to AD. Is it clear? So, what we have found in this triangle AFD? So, in this triangle AFD, we have found that the line segment GE, this line segment, passes through the midpoint G of the side F, as well as this line segment is parallel to L or AD, isn't it? Yes. Now, according to the theorem 8.10, if a line segment passes through the midpoint of one side of a triangle and parallel to the another side, then definitely it passes through the midpoint of the third side of the triangle. It means GE passes through the midpoint of DF. Okay, so you can write hence according to A by C or according to theorem 8.10, GE passes through midpoint of DF. This is the third side of the triangle. If G passes to the midpoint of DF, it means what? It means E is the midpoint of DF. Okay, if E is the midpoint of DF, it means this intercept or this distance DE is equal to this intercept, means this distance EF. Okay, so finally you can write that DE is equal to EF. Okay, so what we have found? We have found DE is equal to EF. This one, DE is equal to EF. So here also we have used the theorem number 8.10, according to which if a line segment G passes through the midpoint of one side of the triangle and parallel to the third side or another side, then this line segment definitely passes through the midpoint of the third side of that triangle. So E is the midpoint of DF. It means this distance D is equal to this distance EF. And these two are the intercept, and we are going to prove what? We are going to prove D is equal to EF. And here we have proved D is equal to EF. And now we have proved this statement. It is proved. So you have to also remember this whenever there are three parallel lines and two transversal lines. Okay. If the intercept of one transversal line are equal, then definitely the intercept of another transversal line must be equal. Okay. This is the trick, or you can say this is the concept you have to keep in mind this. Okay.